This is chapter 8, example 4. This is a little bit complicated example, but it shows some of the possibilities out there. So this circuit wants you to add two 5-bit numbers and end up with a 6-bit result. Okay, we've seen that trick a couple times before. We'll need to use that trick again. But now this circuit has a external button that when the button is pressed, the output is normal. When it's unpressed, the output is all zeros. So this is a slight trick we'll talk about in a second. But now let's just crank this problem out. So first step is black box diagram. And this thing, remember, it has a button input on this, and the output is a sum. It actually called out for a 6-bit value. You're adding two 5-bit values, it could create a 6-bit value. And so that looks good. Let's just do the first part of this circuit first, and then we can come back and fill in the last thing. Okay, we know it's adding numbers under the control of a button. Let's just get it to add numbers first. So the only way we know how to do addition is with a ripple carry adder. This is going to be adding A plus B, and they're both 5 bits, and it's going to have a 5-bit sum. So we're going to play the same appending trick on this thing, which is going to be, this is a 5-bit output. We'll put a note on there. So this becomes a 6-bit value, and that looks good for now. Okay, so this is very much, at least to this point, looks very much like the previous problems. We have to deal with this button here. Now, this is a slight trick. It's used quite often in digital design. You need to put it in your bag of tricks. So the idea is with an AND gate, if one of these inputs is 0, which is, this is my ground symbol, which is equals 0, the output is always 0. It doesn't matter what this input is. Conversely, if this is a similar circuit, if I tie an input to 1, this is my symbology for tying it to 1, this output here is the same as the input. So what this means is we have the ability to, based on this non-X signal here, we have the ability to make the output flow through if the input's a 1, or we can make the output 0 if the other input's 0. So we will draw this the long way using 6 AND gates. This is it's 6 wide, and I'm going to give myself a little bit more room there. Okay, so we'll give this a name. We'll call it Val. So this is Val. Let me get this right. Okay, looking good. What I need is the other input for this AND gate is going to be the button, and that's going to go to each of these things, and then I'm going to put these all back together with my append signal, and this is going to be sum. The way it's hooked up, if this button is pressed, that means the button is a 1, and all these AND gates get a 1 input on it, which allows the other input to the AND gate to pass through. And so that means if the button is pressed, this input's a 1, this output is going to be this input. And that's true for all these AND gates. Now, if the button is 0, that means all these AND gates have a 0 input, all the outputs are going to be 0, and the sum output is going to be all zeros. So that's the trick. Certainly we're going to talk about that later in another chapter, but that's the trick for now. This is kind of clunky notation here. Oftentimes you can substitute it like this, and people will know what you're talking about. and if not, you can leave a note on it. So this works. Gets a little clunky. If you can get clever and write it, do something like this and write a note, that's just as well. So this is a special circuit because it does have a control of sorts, and it's controlled by this button. And so this is our first external control circuit.